G'day all, and welcome to this video series on how to get consistent, excellent sound out of your church's sound system. Now, I say church sound system, but the truth is that these principles that we're going to be learning will work for any sound system in a club or a small venue. It's just that I know there are a lot of churches that struggle with this challenge of getting consistent, excellent sound week after week from their sound system. And we're going to take care of it all right now. So without any further ado, let's get cracking. So what is a sound system? Believe it or not, all sound systems, they're just trying to do what this little system over here does, which is take a bunch of sound sources like this, say a microphone or maybe a guitar like this, and then mix those inputs, maybe add some EQ, some tonal changes, maybe some effects, and then amplify that through an amp, and then reproduce that sound through some speakers so that the audience can enjoy that result. Now, this little system here can mix up to 3 inputs, say for a vocal mic, a guitar, and maybe a CD for backing. So no matter how big or small your system is, it's kind of basically doing what this system is doing. I had the pleasure of working for Michael Jackson for a few years on one of his massive world tours. Wow, that was a lot of equipment, but amazingly enough, it was really just a big version of this little setup. I mean, there was more to it than that, but it was basically accomplishing what this is doing here. Now, on a mixer like this, it could do that for dozens of channels. In fact, this particular one can handle 24 channels, so you could have, say, 8 drum mics, 3 guitars, keyboards, say 6 vocalists, and still have 4 open channels for other inputs. Same as the little version, but a system built around a mixer like this would have a few other components. It would need an external amp and speakers, where this little guy over here has all of that built in. Great for coffee shops, great for, small to medium-sized church. Now, in fact, let's look at an overview of a standard sound system. In a typical sound system, you have your sound sources that feed into a mixer, which then feed into some amps and then onto the main speakers. Now, there are other things like effects and monitors that we'll look at another time, but for now, that's about it. So how do you connect all of the mics and stuff, all of those sound sources on stage out to the mixer in the middle of the room? Now, you could run a bunch of messy cables with all the all the inputs going out on just individual cables, but a far better way to do it would be by using a snake or a multi-cable. And there are a few different ways for the signal to get out to the stage, to the mixer. There are fan to fan, which fan out to a bunch of cables on either end. There are fan to box that terminate into, from a fan on one end to an input box on the other. There are also some that just have input panels that terminate with a plate on the wall. You sometimes see them in some installations that make it easy for you to just plug straight into the wall. Now, there are also even digital snakes that allow you to have, say, a wall panel on the stage area, and all of those channels are transferred through a single network cable, sometimes carrying hundreds of channels. Really cool way to save on all of those copper wires. So it kind of doesn't matter which type of snake you use, the principle is the same. Get all those sounds from the sound sources on the stage to make their way to the mixer so that they can then be mixed and then sent out to the amps and speakers. So you can imagine all of the inputs coming from the stage into a stage input box, right? It kind of looks like this. We have a mixer connected to the input box up on stage waiting for all the sound source inputs. So in this example, we could bring in, say, a drum kit. 8 drum mics could easily go into this input box, a couple of guitar amps, which could come in through the various mics that are miking up those guitar amps. Say a bass guitar could have a direct out of the amplifier going straight into an input box. Say an acoustic guitar which goes to a receiver, which then gets plugged into the input box, and then a whole bunch of microphones. So obviously all of these guys, they all come into the input box. Some guys directly, say in the example of the drum mics and the vocal mics, the acoustic guitar would go through a transmitter, and then the receiver would get plugged into the input box. Now, note that the snake that goes from the mixer to the input box can kind of go both ways. All of these guys are going from the stage out to the mixer, but you can also send back some of that signal back in the form of monitors that are on stage so the musicians can hear themselves. Now, it might not have occurred to some of you that the musicians would have a hard time hearing themselves. When you think about it, all the main speakers are aimed out into the audience, and the band doesn't have, if the band doesn't have anything aimed back to them, the only thing they'll be able to hear is the sound reflected off the back wall kind of a half a second later and kind of all muffled. Not really good for keeping time. So the way to fix this is to send some of the mix back to the stage in the form of on-stage monitors or even those in-ear monitors. That way you can have independent mixes for the main mix here, that's for the audience, and along with the use of aux sends here, or monitor sends, we can send a completely different mix back to the musicians and the vocalists. And here's the thing, the musicians and vocalists on stage may need completely different mixes. Maybe the lead vocalist wants just a little drums for timing and a lot of piano to help with pitch, and then a little background vocals. Maybe the bass player doesn't need any drums at all because he is physically standing right next to the drummer and doesn't really, can hear him perfectly just through the air. Maybe he just needs a little vocal and a lot of rhythm guitar because the guitarist is standing, say 20 feet away. Also think about this way. Sometimes there are really large stages with a guitarist, off to the side, say 50 feet away from the drummer. If the rhythm guitarist is relying on hearing the drummer through the air, then she'll be hearing the drums about 50 milliseconds late because sound travels at about through the air at about a foot a millisecond. I've actually had that happen when a really good guitarist is consistently playing late. I just added a little hi-hat and snare to her mix and she tightens up just like that. So let's go back to an illustration like here that will show the signal flow from the microphone that makes its way through the input box, then to the mixer, and then through aux sends or monitor sends out to an onstage monitor or an in-ear monitor. So if we're looking at this signal flow, where are the places that it could fail? First thing I would look at is the input box and then the back of the mixer. This is a classic place for things to fail if you can't hear the microphone or you can't hear the microphone through the monitors. Have a look at the input box and have a look at the back of the mixer because a lot of people start plugging things in and unplugging things. That's the first place that I look at. Now, if everything is good from there and you're actually getting signal into the mixer, the next thing I would look at is the monitor send up. Also, is the master of the monitor send up? And then the next things I would check are things like, is the amp on that feeds the onstage monitor, and are all those connections okay? In the in-ear monitor area, then you've got to deal with things like the wireless troubleshooting. Are they both on the same frequency, the transmitter and receiver? All of those kind of things there. So this is kind of a good way to look at the signal flow right from the microphone all the way through input box, the back of the mixer, aux send, master, the amp, and just basically all the connections all the way through to the monitors. Let's look at a little bit more of an advanced one right here. Let's imagine that we have someone with in-ear monitors and they say that they can't hear the hi-hats. Now, the first thing you ask them is, can you hear everything else? And they say, yeah, I hear everything else. So if they hear everything else but not the hi-hat, the first thing you can do is you can absolutely say, look, their in-ear monitor receiver is working. The transmitter is working. You know that for sure. In fact, the line that's feeding the transmitter is working. Everything looks good. And you know what? Everybody else hears the hi-hats. So you know that the hi-hat mic is good and the line that's going in your mixer is good. So what's going wrong? I guarantee you the aux send is probably not turned up for that hi-hat. Once you turn that up, everything will be fine. So do you see how getting a rock solid idea of how sound flows from one place to another, it's crucial to troubleshooting, right? Otherwise, really you're just guessing and no one wants that, right? Now in the next video, we're going to tackle one of the top 5 gremlins in audio, and that's feedback. Right? Feedback is a problem that just screams amateur and you don't have to put up with it. I'll show you 3 specific ways to kill feedback once and for all, and also how to use some really cool toys in the dynamic processing department, which are compressors and gates. A well set up compressor and gate are what I like to call kind of auto engineers, as they cure some of your biggest audio challenges on autopilot. You'll absolutely love these explanations and demonstrations. So until next time, I'm David Wells, and ciao for now.